In this video, we're going to explore the concept of code blocks in Python using the Spyder 5 IDE and its inbuilt debugger. If you haven't already done so, follow my previous video which takes you through the installation of Anaconda with the Spyder 5 IDE, and it's recommended to overview procedural programming, as this video very much continues on from my previous video which discusses procedural programming. Okay, so this video has an associated written guide and you should be able to access all the code from it, and you can just copy and paste it directly into Spyder. Sometimes with WordPress it's better to zoom in so the margins become smaller and you'll be able to view the screenshots in a bit more detail. Okay, so let's just have a look at the generic outline of a code block. So you've got code not belonging to a code block that's carried out procedurally. The code block begins with some sort of statement normally, and then a colon is used to indicate the beginning of a code block. Now every line of code that belongs to the code block is indented by 4 spaces. Normally at the end of the code block you'll leave a blank line. This is optional, but it does make the code easier to read. So let's start with an if code block. So the if code block is in response to a condition, and if the condition is true, the if code block is going to execute all the code in the code block. And if the condition is false, then we're essentially going to skip over the code block. Now if we go to Tools, Preferences and then Editor, clicking Show Indent Guides and Show Blank Lines will help a lot here. Because when we indent code, we indent by 4 spaces, so you'll see the 4 characters denoting the space. And you'll see a vertical line just before these 4 characters, and this denotes the indent guide. And to the left hand side we've got the line numbers, and what we can actually do is set a breakpoint which we can run the debug from. So if we select debug, what we're interested in is launching the debug itself, and at this moment just step and stop. And you'll notice that these buttons are also on the main toolbar, so we'll just use them here. So let's start the debugger, and if we want to stop it we can just select stop, and then we're taken to the next prompt. Okay, so let's start it, and this time we're going to step through. Okay, so you see to the left hand side there's a blue arrow. Now it's under the breakpoint, so it's kind of hard to see. So we're on this first line, and when we execute it we create the object name condition, which is a boolean, which we set to true. Now we're on the next line, which is the if statement. So we're going to check whether this condition is true, and we've explicitly written this to make it clearer. And because it is true, when we select step, we're going to enter the code block. So now we're in the code block and we're just going to execute every line of code within the code block. So we'll execute the first print statement and then the second print statement, and then we're going to return. So that takes us to the end of the script file, and if we step through again we'll exit and be taken to the next prompt. Okay, so let's just update this condition to false now and compare the difference. So if we just run this we see actually that nothing happens. So let's go through the debugger. So we've got condition is false, so conditions assigned to false and it's the type bool. And now we're on the if statement and the condition is false this time. So this means that we don't enter the code block and just go straight to the end. So therefore we don't execute any of the code within the code block. So all we have is the first line of code executed, which was independent of the code block. Now because condition itself is a bool, we don't need to explicitly specify whether it's equal to true or false. We can just specify it directly if condition, and we see that the code runs in an identical manner to before. Okay, so what I'm going to do now is take the last print statement out of the code block. So to do this, I'm going to unindent it, and I'm also going to leave a space so it's clear that it's separate from the code block. So if we just run this code, it looks like it executes in the same manner as before. However, there's some slight differences, and we can see this by using the debugger. Okay, so the first line assigns true to the object name condition. Then we've got the if statement, which checks whether this condition is true, and it is, so we enter the code block. And then we execute the print statement within the code block. And this takes us to the print statement outside the code block. And then we execute this, and we've reached the end of the script file, so we see return. Let's update the condition to false and rerun the debugger. Now we see the condition is false in the variable explorer. Then we check this condition with the if statement and we see it's false, so we skip the if code block and we're taken directly on to the print statement outside the if code block, which is executed. And as we're at the end of the script file, we see return. So we can think of procedural programming as being in a car, and the car is essentially driving on a straight road and there's no turns. Now when we get to an if statement, it's essentially a question of whether you're going to take a junction. And we can add an else statement that's associated with the if statement. And instead of asking the question, are you going to turn left, i.e. if, or just stay still, you can ask the car whether it's going to go to else instead. So we can think of this as a switch. So a switch is going to have one of two values, on or off, true or false. And if the switch is on, then we can associate this to the if code block. And if the switch is off, we can associate this to the else code block. Now, we don't specify a condition for else because by definition, it's going to take the opposite of the condition specified in the associated if code block. So it's going to be whatever the opposite condition of the if statement is. So in this case, it's going to be if the switch is false. So let me just restart the kernel and we can run through the debugger again. So in this case, we're going to assign false to the switch and it displays in the variable explorer as a bool. Then we check this if condition and it's false, so we're taken directly to the else code block. And we're going to execute the code within the else code block. And then we're going to execute the code that's not within the code block. And then we're at the end of the script, so we're going to return. Let's update this to true now and rerun it. So now the switch is going to be assigned to true and it displays in the variable explorer. We're going to check this if condition, and because this is true, we're taking into the if code block. So we execute the print statement within the if code block, and then we're taken outside the code block. And of course, because we use the if code block, we skip the else code block entirely. So we execute this line of code outside the code block, and then we see return. Now, we've been working with a switch, which essentially is a bool, and the bool has two values, true and false. And we've got the conditional logic is equal to and is not equal to, which basically gives us the if and the else. If instead we work with a number, then we've got a number of different comparison operators. So is the number greater than 6? Is it less than 6? Is it greater than or equal to 6? Is it less than or equal to 6? Is it equal to 6 or is it not equal to 6? And as a consequence, we can set up a number of associated code blocks, which are going to search for different conditions. So we've got our if code block, is the number greater than 7. And then we can add an elif code block, which stands for else if. And we can ask, is the number greater than 5? Then we can set up another else if code block, is the number greater than 3? And then we can set up an else code block. So if we continue the analogy of a car, we can think of this as a roundabout. So each of these conditions is a sign for a junction on a roundabout, and the code block is the junction. So if you follow the sign and go up one of the junctions, you're basically stuck. You can't turn around and get back to the roundabout. So let's just debug this and we'll discuss it in a bit more detail. So let's run through the debugger. So the number's set to 6. So when we step through this, we'll see 6 display in the variable explorer. Now we're taken to the sign at the if junction, and we are asked, is the number greater than 7? And we say no, so we continue going around the roundabout. And we are asked, is the number greater than 5? And the answer is yes. So we're going along this junction. So we're entering the code block. And so we are driving up the junction. So we see the number is greater than 5. And now we've executed all the code within the code block. So when we select step, we're taken outside the code block and directly to this print statement. So the analogy of the roundabout is pretty good because the number greater than 3 is also true, but we've already taken a junction, so we can't take this path. Now, if we wanted to, we could instead set up a road configuration like this. So we would have an if statement, and then we would have a nested junction after it. So in order to do this in Python, we need to use another indentation. And at each indent level, we need to start with an if. And beside all these spaces, you should see Spyder's indent guides. So you know you've got 4 spaces for each indent. So let's run this through the debugger. So we've got the number and it's assigned to 6. So we're taken to the if statement and we're asked, is the number greater than 7? And it's not. And as a consequence, we skip this junction and all the subjunctions associated with it, and we're taken directly to the else code block. And then we follow the junction within the else code block, i.e. the print statement, and then we're taken to the print statement outside the code blocks. And then we execute this and we're at the end of the script. So let's update the value to 9 now and rerun the debugger. So now the number is equal to 9 and we see this in the variable explorer. Now we're on the if statement, it's true, so we proceed to the code within this code block. Now we're taken to the nested if statement and this is also true. So we're taken to the code within this code block. So we're at the end of this nested code block. So when we select step, we step out of this. And we've also reached the end of the code in the original if code block. So we step straight out of this and we're taken to the line of code that's outside of all the code blocks. So we execute this and then we see return because we're at the end of the script. We can also set up a code block which iterates the code within the code block for a certain number of iterations, and for this we need an iterable. So recall in the previous video we talked about the range object at the end, and the range object can have a variable number of input arguments, start, stop and step, and if all 3 of these are specified, we've got start, stop and step. If only two are specified, we've got start and stop, and step is defaulted to 1, and if only one is specified, then we've got stop with start defaulted to 0 and step defaulted to 1. So let's just create a list of this range object so we can view it within the variable explorer. So we see that we've got a numeric index and we've also got a numeric value. And in this case, they're both the same. So let's just rename this as iterable. And then we can construct a for loop. So to do this, we use the keyword for, and then we create a loop variable. And this is just an object name, and it can be any object name as long as it follows the rules of snake case. And then we're going to look in an iterable and then use a colon to begin a code block. So in this case, we're just going to print hello. And now let's just restart the kernel and run the script. So we see that we've got hello printed out 5 times, and this is because we carried out the loop for every single value within the iterable, i.e. 0, 1, 2, 3, and 4. So let's just create this list range object so we can view it to the right hand side. And what we're going to do is now debug the code. So let's create our iterable, and we see the range object displaying the variable explorer. And now we're at our for loop. And we can think of this top line as an assignment statement. So what it's going to do is assign loop variable to the value of the respective index. So because it's not been ran before, it's going to take index 0 and the value 0. And then it's going to carry out the code within the code block, so it's just going to print hello. And then it's going to ask, does the iterable have another index? And it does. So we move on to index 1 and assign the value of 1 to the loop variable. And then we enter the code block and we carry out the print statement. So we see hello display on the console again. Okay, so the next index in iterable is 2 with a value of 2, so loop variable is assigned to 2. We enter the code block and print hello again. Now we have a look at the next index within iterable, and it's 3 with a value of 3, so loop variable is 3, and we enter the code block and print hello again. Now the next index in iterable is 4, and it's got a value of 4, so loop variable is updated to 4, and we entered the code block again and print hello. Now we have a look in iterable for any other index, and we see that there's none. So this means we exit the for loop and return displays because we're at the end of the script. And if we select step again, we're taken into the next prompt. Okay, so let's just restart the kernel and simplify our for loop. So this loop variable is a number, so let's just call it number or num. And we use the line above to define iterable, so let's just do this directly. And we can remove these unnecessary lines of code, and if we run the script again, we get the exact same result. Okay, so this loop variable num is actually accessible within the code block. So we can print num out instead of hello, and we see the values 0, 1, 2, 3, and 4. And if we wanted, we could use these in some sort of calculation. Recall that when we multiply an int by a string, we replicate the string. So we can begin to create some interesting patterns, such as a right angled triangle. And then we can take an interesting challenge to create an isosceles triangle. So here you're going to need to use the loop variable, and you're actually going to need to decrease the number of spaces before the triangle. And then you're going to need to increase the number of stars for each line within the triangle. And you should get something like this. And we can actually turn this into an arrow by using a simpler for loop. So it's going to give us 7 spaces and then a constant number of stars on each line. So 7 spaces and 3 stars. And let me just fix that so it is actually a space and not just more stars. And then recall that Python uses 0 order indexing. So we're actually starting at 0, giving us a blank line to begin with. So let's just start at 1 and we can remove this blank line. And we can also change the gradient of the triangle by changing the step size. So it's a pretty good way to conceptualize 0 order indexing and also the range object. So if we want to add an upside down triangle to make this a double arrow, what we need to do is change the step size to -2 and then reverse the start and stop. But we need to take into account that we're using 0 order indexing. So we're inclusive of the lower value and exclusive of the upper value. And this essentially means we need to change this to 9 and 0 and we get the double arrow as expected. So I'd recommend that you play around with this and try and make some different types of triangles with different gradients and so on, because it's a really good way to visualize how a for loop is working. Okay, so it seems that my Spyder just crashed, so let me just create a range object. And we want to view it within the variable explorer, so we'll convert it to a list. Okay, so to the left hand side we see we've got this integer index starting at 0 in steps of 1. And then to the right hand side we've got the values which are defined using the range object. So 1, 3, 5, 7 and 9. So we start at 1 and we're going in steps of 2 until we reach the upper bound 10. And it's the value to the right hand side and not the index that becomes accessible for the for loop. So this becomes num, and we can see this by the number of stars that are printed on the console. So let's now create a list greeting that has 4 words. So it's got hello, goodbye, it's got planet, and it's got earth. So if we look in this list, the loop variable is not going to be a number, it's going to be a word. And let's update the list to greeting and just print the word. And then if we restart the console, let's just run this line of code and view greeting within the variable explorer. So we've got index 0, 1, 2 and 3, and then we've got the values hello, goodbye and planet earth. And when we print this, now we just get the values. So we've got hello, goodbye, planet and earth printed in the console. So in other words, the list is a collection or a iterable, and it's got a numeric index which the for loop can use. But so is a word itself. So what we can actually do is set up another for loop, for letter in word, and print the letter. And this gives us the individual letter of each word. Now, we can actually combine both of these to create a nested for loop. And say we want to print the letter, and then after each word we just want to print out a space. So notice how the indentation works here. That print space belongs to the outer for loop, not the inner for loop. So this means that we go to the first word hello, and then we print every letter in it individually, and then we print a space. Then we go to the next word, which is goodbye. We print every letter in it and then a space. And then we go to the next word, planet, print every letter in it and then print a space. And then we go to the word earth and then print every letter in it and then print a space. So if we go back to the list greeting, which had the numeric index and the string value, when we used the for loop, we only got the string values. To get both the numeric index and the string values, we can create an enumerate object. So let's run this line of code and view it within the Variable Explorer. So what we want to do is create an object that has both this index and value. And we can do this with an enumerate object, which doesn't display well in the Variable Explorer. So what we need to do is cast it to a list so we can view it. And now that it's cast to a list, we see the value is now a tuple, where the 0th index is the original index and the first index is the string. So instead of value just being a single value, it's a tuple with 2 elements, and we can access both of these elements using a for loop. So let us just explicitly specify a tuple. So we'll just call this IDX and value for index and value in greetings enumerate list, and we'll just print the index and the value. So for each iteration, it's essentially unpacking the value to the tuple. So it does it positionally. So IDX is going to be set to 0 and value is going to be set to hello for index 0. And then for index 1, IDX is going to be set to 1 and the value is going to be set to goodbye, and so on. And within the code block of the for loop, we can create some calculation involving both the IDX and the value. And if we just multiply them together, we get the output that we expect. And we can simplify this code by using tuple unpacking. So let's just explore the concept of tuple unpacking. So let's open up a new script and restart the kernel. So let's create a new tuple with object names that aren't yet defined, and then assign the output to a tuple of matching dimensions. So the tuple 1, 2. Now num1 becomes the value 1 and num2 becomes the value 2. So essentially we've assigned 2 variables using one line, or assigned 2 variables using a tuple. Okay, so now let's create the variable x, and it's going to be hello, and the variable y is going to be goodbye. Now to the right hand side, what we're going to do is create a tuple yx, and this is going to take on the original values of goodbye and hello respectively. And to the left hand side, we're going to assign it to the tuple xy. So this line of code swaps x and y. And in Python, we can simplify this by removing the parenthesis on both sides, which unpacks the tuples. And as long as both sides have the same number of elements, this will work. And as you see, the code swaps x and y back, so they're back to their original values. So now that we've got a feel for tuple unpacking, let's just restart the kernel. And then to the top, let's have a look at our enumerated list. And we can unpack this tuple using the for loop by just getting rid of the parenthesis. And I just want to make it clear that IDX and value are input arguments in the print statement, and they're not input as a tuple here, so that's why the parentheses are still here, because they're required for the print statement. So we see with the tuple unpacked that it works in the exact same manner as before. It is also possible to loop through a dictionary. So a dictionary has key value pairs, remember? So let's just create a basic dictionary that has the key being the single letter for a color and the value being the full name of the color. So we'll just have a red, green, blue dictionary. And we can loop over the keys, and the keys are list-like. So for key in colors dot keys, and just print the key. And the values are also list-like. So we've got a similar expression. So for value in colors dot values, print value. And notice that we're using plurals for the keys and values and singular for a single key or value. Now, the dictionary also has the method items, which gives key value pairs in the form of a tuple. So we can think of this as similar to an enumerated list. And we can explicitly specify this as a tuple, or we can use tuple unpacking. Okay, so let's run the first cell to create the dictionary. And now let's have a look at colors.keys. So we see it's like a list. And when we run the for loop, we're going to get every single key printed out on a new line. Okay, moving on to colors.values. Once again, we can see that it looks like a list. And when we run the for loop, we're going to get every single value printed on a new line. And now let's have a look at colors.items. So if we have a look at this in the variable explorer, it looks like an enumerated list where every single item is a tuple. Obviously it's not numeric, the 0th index isn't numeric, it's the key instead. And for loop works as expected, printing the key and value for each item separately on a new line. We can also define a new function using a code block. So for this we use the keyword def, then we've got the function name, and then we've got parenthesis for any input arguments, and then a colon to begin the code block. So in this case, we're not going to take any input arguments, and all the function is going to do is print hello world. So when we run this code, we don't see anything happen, and we see nothing displayed on the variable explorer. But if we type in dir in the console, we see that the function is defined. And if we type in the name of the function within the console, we just get told it's a function. And recall we get this behavior for an inbuilt function such as print. So to call the function, we need to use parenthesis, and when we do so, we see that hello world gets printed to the console, i.e. the instructions defined in the function's code block are carried out. To the top of the function, we can create a multi-line docstring. So when we type in triple quotes, it will give us a template. And here we can just say that it prints hello world. And then we'll need to run the script to redefine the function within the console's namespace. So now, when we type in the function's name with open parenthesis, we'll see the docstring that we created. And we'll see a similar behavior if we do this with an inbuilt function such as print. And otherwise we can use the function in the exact same manner as before. So let's update the script to define the function and then to call it. And then we're going to set the breakpoints and run the debugger. Okay, so in the first line we're defining the function. And once we've defined this, it's not going to display in the variable explorer, but it will be available to call. And when we go to the next line, the function is going to be highlighted. Now, we can step into the function or run the current line. So if we run the current line, we just execute the function and we get taken to the end of the script. Now, if I repeat this, and instead select step into, then I can see in more detail how the function works. Okay, so let's start the debugger. We're going to define the function. Now we're going to call the function and we're going to step into it. So this takes us to the top line of the function, and this is where any input arguments are going to be supplied from the console's namespace to the function. In this case, there are none. So when we select step, we're just going to be taken onto the print statement. Now the print statement is also a function, so we could step into this, but this would take us into Python's internal workings, and we're not interested in this at the moment, so we'll just select step. So we'll execute the print statement, and then at the end of this, we're going to return from the function's namespace. And then because we're on the last line of code, we're going to return from the end of the script. And if we select step again, we're going to exit the script editor and be taken to the next prompt in the console. Okay, so let's have a look at a different function now. We're going to essentially make a unit converter that will convert from inches to centimeters. So there's just a simple conversion factor of 2.54. And so we're just going to call the function inch to centimeters, and we're going to have the input argument being input inches. And then we're going to create this variable output centimeters, which is going to be 2.54 times input inches. And now we're going to use a print statement to just print output centimeters. Let's also add a docstring. So we type triple quotes and generate. So input inches is going to be of the type float. And it's going to be the input in inches, which is fairly self-explanatory from the actual name of the input argument. So it's going to print the output to the console, and it's not going to have a return statement, so that's why it says returns none. We'll touch on this in more detail in a moment. So let's run the script, and we see we've got inch to centimeter, and we can access this, and we can print out the value of 2 inches in centimeters. So recall that we can explicitly type the input argument, or in this case, because it's a positional input argument, we can just specify it using the int directly. And in both cases, we get the same value printed. Let's now try and assign this to an output length 1. And we'll change this to 1 inch. So we still get 2.54 printed, but the output is a none type object. And this is because we used the print statement, which has no return value, and we have not defined a return value in our function. So if we wanted to return output centimeters, all we need to do is change print to return. And return isn't a function, so you generally use return without parenthesis. So it's a keyword similar to def in the line above. So let's just update the docstring to state that it's just going to give the output centimeter. And then what we're going to do is relaunch the script, which will redefine the function inch to centimeters. And then we're going to retype the last line of code, and we see that the docstring has been updated. It's actually displaying a wee bit funny, this docstring. I'm not sure why. But when we assign it to an output, the output now displays in the variable explorer with the value 2.54, and it's the type float. Now the return statement can use parenthesis, but generally good practice not to use the parenthesis because, as I mentioned, it's a keyword and not a function. The reason that I'm touching upon this is it's just quite common to see it with parenthesis. So you may be unsure whether you were to put them there or not and what the difference was. So let's just touch on this in a bit more detail. It's similar to the keyword del, which is often used with parenthesis, but it's a keyword and it's better practice not to use it with parenthesis, although I commonly do because I came to Python from MATLAB and that's the way it was done in MATLAB. So since we're using a lot of the keywords, it's worthwhile just importing keyword and having a look at the list of keywords. So you'll recognize many of these as we've already used a lot of them, and here is return. So all of these are keywords and they're used without parenthesis. And many beginners, myself included when I began, thought of these as just additional functions, but they're different from functions. and they're called without parentheses. We can update our function to use a keyword input argument instead of a positional input argument. So in order to do this, we just assign it a default value. Now we've only got one input argument for our function. However, if you've got a function with multiple input arguments, the positional input arguments need to be stated before you use any keyword input argument. Okay, so let's just restart the kernel, rerun the script, and now we can call the function and assign it to length 1. With no input argument defined, it's going to default to its default value 1, so we're going to get 2.54. And we can call the function and specify this keyword input argument and assign it a new value. Now because this only has a single input argument, we can just define this as a positional input argument and it will still work as expected. However, it's better practice to always include the keyword argument and assign it to its new value, because it allows for more flexibility. When functions have multiple positional and keyword input arguments, then you only need to specify the keyword input arguments that you want to change, and any that you don't specify will default to their default value. So one important thing to conceptualize when you're dealing with functions is the concept of scope. So what I'm going to do is I'm going to create 4 variables, a, b, x, and y. And then I'm going to create a function that has keyword input arguments that are called x and y. And it's going to be a very basic function that's just going to return the sum of these 2 values. But the important point to note is that these keyword input arguments are completely independent of the variables x and y. And we're also going to include a line which calls the function. So what we want to do is run the debugger, and we're going to create the variables a, b, x, and y. Then we're going to define the function, and it's going to be accessible in the console's namespace, but it's not going to show in the variable explorer. Now we've got the function highlighted and we can select step into. Notice when we do so that x and y are now 3 and 4 and not 1 and 2. So in line 13 we call the function and we provide the values 3 and 4, and when we step into the function on line 8 we're providing 3 and 4. So that's why 3 and 4 display here. Now there seems to be a bit of a bug because the function can only work with arguments that have been supplied to it using the input arguments. So this function cannot access a and b, so a and b should not display in the variable explorer just now. So when we select step to move into the next line, we're going to create this variable summed, which is going to be x plus y, and sum's going to be in the function's local namespace as well. So the function's local namespace will have x, y, and summed. And then in the last line of the function, we're going to return summed. So what this does is it will assign the value summed to the output mySum on line 13. And this is because we're assigning the function to an object name, as we call it. So when we select step, we're actually going to return out of the function now, and we're going to go back to the script. So notice what happens is that we've got mySum now, sum disappears, and we've got a, b, x, and y, which were defined earlier. So the x and the y in the script have been completely independent of the 3 and 4 provided to the function when the function was called. So in other words, the function is more or less a closed system with an input and output valve. So things can only be taken into the function using the input arguments, and things can only be returned from the function using the return statement. So one of the useful consequences of that is that you can have variables in your console that are the same as the keyword input arguments in a function or positional input arguments in a function, and your code will continue to work without breaking the functions. So this can be really useful in libraries such as matplotlib, where you're going to plot x and y data, and the function calls these variables x and y. So calling your data x and y will not break the functions in this case, and it can make your code more readable and easier to understand. Let's create a new function called BMI_calc, which is going to take the height in meters and the weight in kilograms, and it's going to calculate the person's BMI, and then it's going to return the BMI. So let's just test this to see if it works. So let me just put in my height and weight, and that's my BMI. So it's given to too many significant figures, so we'll use the round function just to get it to one decimal place. And we see that it works as expected. Now we also have BMI classifications, and we can nest an if, elif, elif, and else block to provide the classification for the person's BMI. So we've got, if the BMI is less than 18.5, the classification is underweight. If they're less than 25, it's healthy. If they're less than 30, it's overweight, and otherwise they're obese. Now, we only have one return statement, but if we want both values, we can instead return a tuple. And we can use tuple unpacking, so we don't need to explicitly specify the tuple. We can also provide a formatted string to print out the BMI and the person's classification. So let's add a doc string here. And the units are fairly self-explanatory. Let's just inform the user that they're going to be floats. The BMI return will be a float. It's dimensionless. Some abbreviations, body mass index though. And classification is going to be a string. And it's just a classification. So this function demonstrates that we can nest if, elif, and else blocks within a function to carry out different code depending on the condition. So I can test this at different weights. So if I lose 1 kilogram, I go from overweight to healthy. And before I went on a diet, I was classified as obese. So making progress, and the BMI calculator works. Let's now create another very basic function called SumMyValues, and it's going to have 3 positional input arguments, A, B, and C. And all it's going to do is return the value of A, B, and C added together. So let us just highlight this code and run it, and we'll call it with just some basic values 1, 2, and 3, and we get the value of 6. Now notice that the input arguments look very much like a tuple. In fact, let's create a tuple from them. So we can actually call the function using a tuple if we put a star in front of the tuple. And notice once again that we get the value of 6. Now we can change this function to have keyword input arguments instead. So let's call this function and assign a value to each of the keyword input arguments. So A equals 1, B equals 2, and C equals 3. Once again we get the value of 6. So notice that this looks similar to a dictionary. So let's just change the keyword input argument to a key and change it so it's got key value pairs and call this dict1. And we can call this function using 2 stars and then the dictionary. So this has a consequence when we want to create a function that has a variable number of positional or keyword input arguments. You often see star args or dash star star keyword args, which stands for a variable number of arguments or a variable number of keyword arguments respectively. So let's modify this function to have the variable number of arguments, and this is essentially going to give us a list that we can use it within a for loop. And so we can sum each of the numbers and return the summed value. So now we can sum my values and we can select 1, 2, 3, 4 and 5. We can select 1, 2, 3 and 4, 1, 2 and 3, 1 and 2, 1 on its own, and no input arguments, which gives the value 0. So this function gives a lot more flexibility than the function that had the fixed positional input arguments. Let's now move on to another type of loop called a while loop. So a while loop is kind of like an if statement. So it's got some condition and then a code block. And if the condition is satisfied, the code within the code block will be executed. Now, unlike an if statement, the while loop's then going to go back to the top and it's going to check the condition again. And if the condition is still true, it's going to implement the code block again. And it will continue doing this until the condition is not true. Now, it's possible that the condition will never ever change, and in such a case you'll get an infinite loop. So in order to do this, you're going to need to left click into the console and press Ctrl and C, and this will give you a keyboard interrupt. So normally you're going to have some condition that's going to change with respect to the while loop. And one of the kind of best ways to conceptualize this is to make a for loop of an iterable and then make an equivalent while loop. So we are going to use this very basic one, for num in range 4, print the number. So we've got numbers 0, 1, 2 and 3. And now we want to convert this to a while loop. So the while loop has no loop variable by default, so we're going to need to define something outside the loop. So let's just set num to be 0, and we're going to say while num is less than 4, print num. And let's just run this loop, and you'll notice that there's no lines of code within the code block to update num. So it's always going to be 0, which is always going to be less than 4. So we're always going to print 0, i.e. we've got an infinite loop. So we need to keyboard interrupt it again. And add this line, plus equals 1. So num's going to be increased by 1 every single time the code block in the for loop's run. And now it works in the exact same manner as the for loop. So in this basic example, it's better to use a for loop because you've got an iterable and it's pretty obvious. In other cases, particularly when dealing with hardware, you may be waiting for something to happen and you're not going to be sure when this will actually happen. For example, your laptop's going to run out of power in its battery. It's more of a complicated calculation, and you would use a while loop, say, okay, while the power is greater than 10%, keep the laptop on. While it's less than 10%, turn it off. So one particularly good challenge to cement your understanding in the previous topics covered, such as the range function, creating your own custom function with a variable number of input arguments, if else code blocks, and a for and while loop, is to create your own custom range function with a solution that uses while loops and a solution that uses a for loop, respectively. So you can pause the video and try and do this yourself, and I'll just go through my solution now. So I'm going to define the function myRange, and it's going to have a variable number of input arguments. We've got the colon to begin a colon block. Then we're going to look for the length of the arguments. And if they're free, then we know that the start is the 0th positional argument, the stop is the first, and the step is the second. Else, if the length is 2, then we know the start is the 0th positional argument and the stop is the first positional input argument. And the step is 1. And if the length of the input arguments is 1, then the start's going to be 0. The stop's going to be the single positional input argument, so the 0th one, and the step's going to be 1. So we can just print the start, the stop, and the step just to check whether the code works. So myRange 10, we've got 0, 10, and 1, 1 and 10, 1, 10, and 1. myRange 1, 10, and 2, all three are defined, so everything's working as expected. Okay, so for a while loop, what we're going to need to do is create some number sequence. And we're going to need to see if the step's greater than 1. So if the step is greater than 1, we're going to set num to be the start. And while num is going to be less than the stop value, we're going to append num to the number sequence. And then we're going to need to increase num by a step, and this is going to be in a while loop. And finally we want to return the sequence. So we can test this out, and it works with positive values and positive steps. Now we can also insert a negative step, so we need to handle this. So we can handle this with an else if. And as the stop's going to be the lowest value in the sequence for a negative step, we can change the while loop condition to while num is greater than stop. So now we can see that this works with negative values as expected. Let's copy and paste the code above and convert this to a for loop. So for a for loop, we need a sequence of known length to iterate through. So what we can do is calculate the number of steps. So we can call this sequence length, and it's going to be the stop minus the start, integer division divided by the step. Now obviously if this step is 0, then we're going to try and divide by 0, which is going to give us an error. So in such a case, we're just going to return an empty list. So with the sequence length, we can create a list of blank values, and then we can set the index to be 0, and we can set the initial value to be the start, and we can tell the for loop for the number in the number sequence. What we want to do is index into the number sequence and update it to the value. Then we want to increase the index by 1 and the step by 1. And this will run for the length of the sequence, and it should work for both positive and negative values. So we can just try it with a few test values. So it works fine for a single stop input argument, and it works fine starting from a negative value and using a step of 2, and it works fine starting from a positive higher value, stopping at a negative value and using a negative step, and it works fine when the step is set to 0. So the code seems to work as expected. Okay, so now for simplicity, we're going to look at a very basic function. So this function is going to ask for an input argument that's a number, and it's going to return the number plus 1, and that's all it's going to do. So we can do this basically in 2 lines. And if we call this function with the number 2, it works exactly as expected. It works with a float. If we try the letter A, then we're going to get this type error because the string's going to try and use concatenation and int's going to try and use addition, and Python doesn't know what you want to do. So it's quite common to get this kind of type error, and when you're designing functions, you should anticipate problems that may be encountered when a user tries to use your function with a different data type. So we can use this assert keyword followed by a check that must be true, otherwise it's going to give an assertion error. And after this check, we can also leave an optional message. So here we see that the number must be of the type int. Now you can imagine in some other cases where you want the number to be greater than 0 or not 0, then you can also assert this. Okay, so we can see it works with the value 2, we get the error for the string A, and now we also get the error for the string -2. So in all the cases that we've seen when we've done something silly, like use the wrong data type, we've got this error and it's basically threw us out the script and said, you've got a glaringly big error, do something about it before you run your script again. So there is a code block grouping for error handling. So you've got the try code block. So the block will test for an expected error in the code. You've got the except code block, and except by default will work on all errors, but you can specify the specific error. And then you can include some instructions to handle this type of error. And you can set up multiple except code blocks to handle different types of errors. After this, you've got the else code block, and this is only carried out if there's no errors in the try code block. And then after this, you've got the finally code block, which is carried out regardless if there's an error or not. So let's create this function number squared plus 1. So we can try number plus 1 because we know if it's going to be a number that this is going to carry out without any issues, and if we input a string, we're going to get this type error. So we can handle this by just setting the number to be equal to 0, and then we can set number squared is going to be 0 as well, because 0 times 0 is 0. And we can also inform the user that this was an invalid number, so the number was set to 0. Next, we've got the else code block. So say we want to calculate number squared, so we can multiply number by number, and then we've got the finally code block, and we want to return number squared plus 1. And this is going to be carried out if the users input a valid number, or if they put an invalid number and instead the alternative number squared of 0 has been used. So we see that this works as expected. So this is just a very basic example of it. You would generally check for a lot of other conditions, and you would probably have if and else statements nested as well. So that's an overview of some of the most commonly used code blocks in Python. Now, for the case of a function, there are some shorthand versions of functions called lambda expressions. So if you've got a very basic function, you can collapse it down into one line. So let me just create this inch to centimeters function again. And let's try and make it more concise. So we can return input inches times 2.54. Now we can collapse this down to one line using a lambda expression. So let me just type it in. Inch to centimeters is assigned to lambda input inches colon input inches times 2.54. So we've got define inch to centimeters, and can see that this is basically an assignment. So we've got inch to centimeters equals lambda. Then both have a colon, To the left hand side there is input arguments. So the function needs these in parentheses and the lambda expression doesn't, because it's more concise. And then the function needs this return statement with a return value, and this is placed on a single line in the lambda expression to the right hand side of the colon. In both cases the function is called in an identical manner. So let's run the function, and we see we've got it defined in the console's namespace, and we can call it and we get this length equals 5.08 as expected. Now let's call the lambda expression. We see we've got it defined in the console's namespace, and once again when we use it we get the exact same value. So if we have a look at its details, we see that it's a function and we see that it's a lambda expression. So I don't know if you noticed earlier on, but when we had a look at the keywords, we seen that lambda was one of the keywords. So once again, it's a keyword and not a function. Now we can update our input arguments to be a keyword input argument simply by assigning it to a default value. So now we can check length 1 and we'll call it without assigning anything to input inches, and for length 2 we'll override the default value. So in both cases we see that the lambda expression and the function both work in the same manner as expected. And just for clarity, let's create a function with 2 input arguments. So it's just going to add the values, and we're going to have the keyword input arguments x equals 0 and y equals 0, and we're just going to return x plus y. So we need to change this to add values. We need to change this to x equals 0, comma, y equals 0. No parentheses around this, and then the return value is going to be x plus y, so we specify this without return. And now let's just create some test cases to call this function. So we can call it with no values, and then everything's going to take their default. We can call it with just x, and then y is going to take its default. We can call it with just y, and then x is going to take its default, and then we can assign x and y. Okay, so if we restart the kernel and run the first cell to define the function and then call it, we see we get the values that are expected: 0 plus 0, 2 plus 0, 0 plus 3, and 2 plus 3. Now we can launch the lambda expression, and then we can launch the code block to run the expression, and we get the same values as before. So we've seen earlier that not all functions have a return value. So let's change this function to be a function that's going to ask for a user's name, and it's going to print something to the user, such as hello user. And we'll just call the username PN for person name, and it's nice and concise. So if we try and convert this to a lambda expression, we've got the keyword input argument PN, and then here what we're going to do is just call the print statement. And this isn't going to return anything, it's just going to execute the print function, which itself doesn't have a return value. So let's just try and call this, and we'll assign it to an object name. And then we can type in the keyword input argument and set it to Philip. And in this case, we can also use the keyword input argument as a positional input argument because we've only got one. So let's run the top code block to define the function, and then let's call it. So we see the print statements on the console, and we see that everything is a non-type object on the variable explorer, and that's because we have no return statement in the function. Now, if we do the same for the lambda expression, once again, we see everything's printed to the console, but once again, everything in the variable explorer is a non-type object because there's no return statement. So lambda expressions are also known as throwaway functions, and they're used just to do something that's short and concise. For instance, if you're working with a data frame and you want to apply some function to data in a column, you may use a lambda expression just so your code is short and concise, opposed to creating your own function that you're only going to use, say, once. Often a for loop is going to be used to create a new list from an existing list by carrying out a series of operations on each of the values in the original list. So for instance, if we have the list that's just a list of the numbers using the range object, what we can do is use a for loop to convert this into a string of row numbers. So we want every number to be a string prepended with R. So let's run this first cell and we'll see numbers display within the variable explorer. So we see the list 0, 1, 2, 3, and 4. And then we want to create the empty list to work on. And then let's actually debug running the for loop. So we can see how the list row numbers is updated as we run through the for loop. And eventually we've got this list of strings, R0, R1, R2, R3, and R4. And let's try and simplify this code down now. So we can simplify this by just getting rid of this first line and merging it with line 6. And we can get rid of line 7 and merge it with line 8. So now we see that it's more concise, but essentially we've got two operations. We need to create this empty list, and then we need to use the for loop to populate it. Now, we can actually use a thing called a list comprehension, where we carry out the for loop within the line that we used to create the new list. So what we're going to do is take this expression that we appended and put this to the left hand side of the new list, and then to the right hand side of this we're going to copy and paste the code from the for loop, and we have no colons, and we don't need to use the append method because we are assigning the object to the left hand side. So you can see where each of these came from with respect to the for loop, and when we run this we get the list created directly without having to create the empty list beforehand and then populate it separately using a for loop. So it essentially has this syntax. So you've got everything in the square brackets and it's expression for the loop variable in the iterable, and you can add an optional condition after that. So for example, if we only wanted even row numbers, we can add a condition if the number mod 2 is equal to 0, i.e. it's even. And now when we run this, we only get the even row numbers. And we could modify this expression accordingly if we wanted odd row numbers instead. Let's move on to something more complicated. Let's try and create a list of coordinates of, say, for example, a chessboard. So it's going to be a letter and then a number for each coordinate. And we can do this by using two for loops. So we've got the letter in a string of characters, and we've got the number in a range object. And all we're going to do is append the letter to the string of the number to the coordinates list. And we can convert this to a list comprehension. So the expression's going to go to the front. And then we've got the outer for loop. And then we've got the inner for loop. Once again, we're ignoring any colon. And because we're assigning the output to coordinates directly, we don't need to use any list methods such as append. And we see that this gives the exact same value as before, as expected. In addition to list comprehension, we have dictionary comprehension. So we can create a dictionary using a very similar procedure. So the expression is going to involve an expression for the key and an expression for the value. We're going to need to loop over the key and the value. And then we're typically going to use the items method from the dictionary. So let's just demonstrate this using an example. So let's just take the hex values for red, green, and blue. And then we're going to use a list comprehension to create a dictionary that only has the one letter abbreviation for each color as the key. So let's say we're setting up a for loop. So we would say for key value in colors.items. And we can enclose this in braces so it's a dictionary. To the left hand side we want an expression, so we only want the 0th character of the key and we want the entire value. And we see that this works exactly as expected. And now I'm just going to add the secondary colors as well as black and white. So in the case of black, we can't take the first character of black because it's already taken by blue. So we can add a condition if the key is not equal to black. So you see when we run this that our output dictionary has all the colors apart from black. And then we can also add this key K at the end and set it to be the value of black in the original dictionary. Now it appears I've made a typo here, so let me just fix that. And then the code works as expected. So the last tutorial video I made covered procedural programming and this video covered code blocks. So this should make you pretty comfortable with inbuilt Python now. Now Python has a multitude of standard libraries and additional data science libraries which all have objects that you can import and use to carry out routine everyday tasks. For example, statistics, random number generating, mathematical operations, and then of course the data science libraries. So in order to understand this, you're going to need to understand how to work between different Python script files to import something from one script file to another script file and to use it. And this is essentially the backbone of the so-called object-oriented programming. And I've put together another tutorial guide which covers this, and I'll leave the link to this in the video description.